Hi. I'm going to talk to you about modulated modularity and moving from mass customization of the early digital architecture to custom mass production or computer-aided mass production. With the rise of digital technology over the last 30 years and the promise of individual liberation by it, it seemed a fully democratic, completely individualized society is about to emerge. A few decades later, we're seeing how big data actually makes us more predictable and manipulable and has created stronger hierarchies in power, as most prominently evidenced by the Cambridge Analytica scandal. Yes, we are more individualistic than ever, but we're also more connected than ever, meaning we're all classifiable data sets for machine learning algorithms. So considering this, is the digital really an enabler of endless variation, or as proposed by the first generation of digital architects, or rather a contingent system of standardization? The way variation is created in the manufacture of digital designs, we could look at digital printing, where, yes, we can print every page different, but it relies on extreme standardization. You have to have the exact right ink and position the points correctly. The same applies for digital screens. This technology has also been applied in building facades in lower resolutions, whereas in some of the more successful designs, the pixel itself has become an architectural detail. This image you might already have seen. Pixelization, or rather voxelization, can be used to create a similar level of automated modularization of form. So that leaves us with the question, what is a good three-dimensional pixel, a module in construction? I would argue that there are two main, somewhat contradictory parameters at play here. One is efficiency, and the other is flexibility, or rather resolution in this context. A lower resolution results in fewer elements, but also fewer possibilities for spatial articulation. If we look at the way construction elements and modules are designed, they are mainly optimized for logistics of mechanical fabrication, transport, and manual construction, not necessarily flexibility. Custom, or rather computer-aided mass production, allows us to rethink some of these parameters in favor of higher degrees of freedom. Still, automated fabrication today is more reliable in repetition. It is easy to automate the production of almost any detail to be produced in bulk. On the other hand, producing a unique part every time still remains inefficient and has a high margin of error. Not to mention the only zero-waste approach to creating non-standard elements is additive manufacturing, where also the margins of error are the highest. So still, through the projects that we have done with PART and our experience talking to engineers in the local wood house manufacturing industry and working on large-scale non-standard projects, the most viable way of producing elements is machining standard stock materials, mostly cutting and milling. This means stock waste is also an issue. These practical constraints can be seen as the conditioning circumstances of the modulated modularity method. It is based on repetitive algorithmic subdivision where the resulting elements can be evaluated for material efficiency. Building on top of this, structural analysis and optimization can be used to determine the materiality and the placement of these elements. All of these practicalities form the reality that builds into a virtual model that defines the modulation of form. The term modulated modularity suggests an algorithmic play on or rigorous modification of modularity. The classical tool of modularization has been the grid. Due to mechanical production and the way of conceiving architecture in two-dimensional drawings, the grid has classically been a projection of parallel axes. Algorithmic means, though, allows us to look at the grid not just as a less constrained periodic subdivision of space, but as a design tool that is adaptable, based on the real, and allows for evolutionary optimization as well as subjective intervention. Looking at the term modulation in philosophy, Gilbert Simondon and Gilles Deleuze give another useful meaning to it. Simondon's definition of modulation associates form and matter with the example of brick molding, where the form is not the direct imprint of the mold, but rather the result of all the forces in the clay and the mold finding their equilibrium. Deleuze, on the other hand, notes a shift in societal control from molding to modulation, namely from form-imposing mode to self-regulating mode. Bringing this kind of modulation to algorithmic architectural design creates another layer in this process. Not only is form modulated by the actual forces and its materiality, but also by the designed algorithmic model that governs these relationships, where the objective and the subjective aspects actually get blurred. Modulation in this context is therefore not a strictly self-organizing system, but a designed system with partially self-organizing characteristics. This dynamic play with geometry has also relation to simulation. When we simulate physical forces on screen, we get a certain feeling for how a structure might behave. This might be a reason why people are watching videos of soap being cut on Instagram, where you get this almost tactile feeling of materiality looking at these videos, or why they download apps to manipulate simulated goo. Something similar happens with dynamic geometric systems. We get a feeling for the geometry almost like a new materiality, or rather formality. The fascination with the developed method of modulation does not really lay in the efficiency of combining constraints and fabrication and construction, but rather developing a behavioral system which reveals a certain emergent formality. Negotiating contradictory goals is where algorithmic design creates the most interesting results. The other, the strange, the unexpected. To borrow words from Manuel de Landa, the virtual is manifested in those situations where intensive differences are not cancelled out. In parts designs, we are using this method of modulation in a way as to reveal the designed virtual model through the process, exploring the effects of the negotiation between the mold and the clay, so to say. Modulation also brings up the question of proportion and rhythm, and through that, a relation to the human body. This in turn could be considered another reasoning for digital architecture to turn from the continuity of calculus to the granularity of data. Modern architecture has often been criticized for the lack of human scale. The new rise in discrete tectonics, arguably connected to automation of assembly, could also be a return to the human scale. Rhythm is the discretization of our environment in space and time. Just as we discretize sounds that we make into syllables to manage the noise of the signal, we are dividing our environment to comparable parts to understand and communicate it. Proportion and rhythm, therefore, are tools for making our environment relatable. Not to mention, edge detection is essential for machine vision, so differentiation is needed. Algorithmic regulating lines operate in a different way than the ones that drawn on classical elevations. Periodic spatial subdivisions reveal how the design surface, for example, the massing of the building, relates to the underlying formal logic. Like isometric lines on topological maps reveal the undulations of the landscape, modulation emphasizes the geometry of the form that it is imposed on and its relation to it. Like the imperfections of the brick coming out of the mold, the modulated surfaces reveal the underlying forces at play in this conception, creating patterns that can be interpreted. So, using algorithmic tools, we are bound to be a lot more precise about following the regulating lines of our automated designs. We are able to set up simple algorithms, rule sets that define relationships within our designs, that then start to govern the design space. Not only that, we can also set parameters within those algorithms that then can be changed on the go based on qualitative and quantitative feedback, creating a possibility for subjective manipulation of this automated process. This creates a duality of human, non-human interaction, the rational and the other. The intention of subjective judgment into the algorithmic model creates greater control on the modulated formal outcome and its reading. And the scale of elements or resolution of the form can be manipulated on the go, creating varying intensities of modulation in relation to the human body and its experience of space. That's it.